Okay, folks, Mr. Brunsvold here. Today we're going to be talking about Lewis structures. Um, so I already taught you how to draw Lewis dot diagrams. Today we're going to be learning about something called a Lewis structure. It's very similar to a Lewis dot diagram, and this is how chemists really represent compounds and molecules when they draw them. Is they draw them as a Lewis structure. It's sort of the tool that we use to model um, compounds and molecules. So what is a Lewis structure? A Lewis structure is similar to a Lewis dot diagram. A Lewis structure is a representation of a covalent compound that uses lines instead of dots to represent the bonds between atoms. And I say here that it has to be a covalent compound. It could also be a covalent molecule, as you'll see when we go through the examples. So here we have methane, or CH4. Sometimes it's also called natural gas. Some of you remember, I think some of you did natural gas for your energy source back when we did the energy source project. So here we have methane. And it's a carbon with 4 hydrogens. Now, when we draw the Lewis dot diagram, it looks kind of like this, right? The carbon brings 4 electrons, and then each hydrogen brings 1 electron. And so we represent the bond with the 2 electrons in between the atoms. Well, in a Lewis dot diagram, we use lines. So this is the Lewis dot diagram. In the Lewis structure, we use lines instead of dots to represent the bonds between the atoms. So here, each pair of 2 dots, we're going to use a line to represent the bond instead. And so this is a Lewis structure over here. So go ahead and take a second and write that down, and then we'll move on to page 2 of the notes. Okay. So, in a Lewis dot diagram of a covalent compound, each pair of electrons is represented by 2 dots. Right? In a Lewis structure, each covalent bond is represented by a line. Right? So in a Lewis dot diagram, we're representing a pair of electrons with 2 dots. In a Lewis structure, we're representing that covalent bond with a line. And so all of these terms are actually equivalent. A pair of electrons, 2 dots, a covalent bond, a line. They really all mean the same thing. It's just sort of different ways of representing the same thing. But the important thing that you need to get out of this is that one line is equivalent to 2 electrons. In a Lewis structure. And we're going to sort of see that throughout our lesson today as we're drawing Lewis structures of compounds and molecules. Okay, so let's take a covalent molecule, bromine. Let's draw the Lewis dot diagram for it, and then we'll convert it into a Lewis structure. So we'll start off with bromine. Bromine is Br. If we look for it on the periodic table, bromine is right here. And so this is one of those ones where when you count across, you want to skip all of these elements in the middle here. So we're going to do that. We're going to skip them. We're going to count 1, 2, 3, 4, 5, 6, 7. So bromine is the 7th element in its group. Now keep in mind, you can also use the periodic table on your iPad, and then if you just click on bromine, it'll tell you the Lewis dot structure. But we're just going to use the Lewis dot structure right here with 7 valence electrons, so 1, 2, 3, 4, 5, 6, 7. Okay, and then we need to add a second bromine atom, right? Because bromine really wants to have 8 electrons, so we need to add a second bromine atom so that they can share some electrons. Okay, so now we've got bromine bonded to bromine. And so we can see that this bromine has 1, 2, 3, 4, 5, 6, 7, 8 electrons, and so does this bromine, 1, 2, 3, 4, 5, 6, 7, 8. Okay, And so they're both bonded together. And we can see that these two electrons right here are shared, right? They're in both circles. So these two electrons are going to become a bond. So when we draw the Lewis structure, we'll draw the 6 electrons on the outside here. Those are still here. The 6 electrons on the outside here, those are still here. But the 2 electrons that are shared, we represent them with one line. Because remember that one line represents 2 electrons. And then this is the chemical bond between those 2 bromine atoms. That's how we represent it, is with just a line in between the 2 atoms. Okay, so hopefully this is making sense. It's not too different from the Lewis dot diagram. The only real difference is you represent the bond with a line instead of 2 dots. Let's do another example. This one is hydrogen chloride. It's also known as hydrochloric acid or stomach acid. Right, this is the acid in your stomach that dissolves your food. And so we're going to have a hydrogen and a chlorine atom. And so hydrogen was right there on the periodic table. That's why it gets 1 valence electron. Chlorine is right here, and just like bromine, there's 1, 2, 3, 4, 5, 6, 7 valence electrons. So we'll give it 7 valence electrons. Then we're going to combine those two together because they're bonded together. If we look at the hydrogen atom, remember hydrogen only has 2 valence electrons for it to have a full shell or a full orbital. So hydrogen is good. Chlorine has 8 electrons. Okay, so everything's stable. And so then when we redraw this, we're going to draw the hydrogen atom, and it doesn't have any electrons around it because its 2 electrons are actually part of the bond. Chlorine will put 6 electrons around it. And then the 2 electrons that are part of the bond will represent that with a line to represent the bond. So again, this line represents the 2 shared electrons by the atom. Okay, and so then let's do one example that's going to have multiple bonds. So here we're going to do trihydrogen mononitride. So we'll draw 1, 2, 3 hydrogen atoms and 1 nitrogen atom. And then again, hydrogen's right here on the periodic table. So each hydrogen atom, since hydrogen is the first one in its row, each hydrogen atom is going to have 1 valence electron. And then we'll take a look at nitrogen. Nitrogen's right here. So it's the first, second, third, fourth, 5th element in its row. So it should have 1, 2, 3, 4, 5 valence electrons. Everything's going to come together then. All of these atoms are going to come together to form some covalent bonds. So we can see that each hydrogen atom has 1, 2 electrons. And we can see that the nitrogen atom, so all the hydrogen atoms have 2 electrons. The nitrogen atom is going to have 8 electrons, right? Because that's how many electrons it needs to have a full shell. And so then our final picture will look kind of like this. So then what we're going to do is draw the Lewis structure. And so we can see nitrogen has 1, 2 of those unpaired electrons. So that's these 2 right here. That's only in the red circle. It's not in any of the blue circles. But then we have nitrogen sharing 2 electrons right here. So we'll draw 1 bond right here. Nitrogen sharing 2 electrons with hydrogen right here. So then we'll draw 1 bond right here. And nitrogen sharing 2 electrons with this hydrogen right here. So then we'll draw 1 bond right here. So each hydrogen forms 1 bond with the nitrogen. The nitrogen forms 3 individual bonds with those hydrogen atoms. All right, so then up next is the problem. So go ahead and work through these problems. You're going to start by drawing the Lewis dot diagrams for each one of these, and then you'll convert those Lewis dot diagrams into Lewis structures. If you have questions, as always, feel free to reach out to me. All right, thanks for listening, folks. Have a good day.